Welcome. My name is Brian Hutchison. I'm a professor at Victoria College, and today we need to talk about solving some linear equations. Most linear equations can be shown as ax plus b is equal to 0, depending on the book you're from, that you like to use or had in your past. Sometimes they say that it's not always equal to 0. It could be equal to some number, but just remember we can subtract, and I'll talk about that in more detail here shortly. But before I tackle a problem that looks a little bit like this, I need to go over some properties of equality with you. Some properties of equality with you. So properties of equality. Every time I start thinking about properties of equality, I like to really picture a set of scales. They're balanced, and honestly, the secret is whatever you do to one side, you better do to the other side. And how a lot of places show is if you have an equation, right, a left side is equal to a right side. In this case, I'm just saying A is equal to B. Well, we have addition rule of equality that basically says I can add to one side some constant C as long as I do it to the other side. And as you progress and get higher and higher, there's all sorts of stuff besides just nice little constants that we can add to both sides. But right now we're talking Math 300, Math 303, and maybe even for some of our college algebra folks. Well, if I can add, I can subtract, right? So we have subtraction, which basically says if you subtract from one side, you better subtract from the other side. It keeps everything in balance. We can multiply. I can do A times C. So still, I have the A and the B, and I multiplied each side by C. Now, I'm not going to lie. We really don't want C to be 0. Multiplying both sides of an equation out by 0 just wipes them out. So try not to let C be 0. And then division. Can you guess what I'm going to write? A divided by C then must be equal to B divided by C. I divided both sides by a constant. But once again, I need to make a very good statement that you had better not let C be 0. Right? We don't like to divide through by 0. It turns your cat Fluffy into Cujo, named Fluffy. Cujo has rabies and mange and, all sorts of bad stuff, and you're allergic to Cujo. So don't divide by 0. Nobody likes Cujo. And if you don't know who Cujo is, read some books. Well, I guess the movie wasn't too bad, but Stephen King. So these are some of our necessary rules in order to solve. These are our rules in order to solve. And when we really start out, we usually see problems like 2x plus 3 is equal to 9. And the directions are going to say solve for x. What does solve mean? Well, since I only have this 1x in my equation, I went ahead and highlighted it. Basically, in this one, it means to me I want x all by itself. Isolate it, get just x to one side and everything else to the other side. And in class, when I talk about this one, I always like to talk about me and the wife dancing. Right? If I step forward, and I'm not talking about that, rave dancing where everybody looks like they're having seizures and lights are going funny. I'm talking about good old dancing, right? Holding each other, dancing. So if I take a step forward with my right foot, what does the wife have to do? She has to step backwards, right? With her left foot. It's opposites. So if I want to get rid of this x, I have two numbers that are really, really interfering with me. The 2 and the 3. Which one should I get rid of first? Well, if you said the 3, congratulations. High five, fist bump, all that fun stuff. If you say the 2, high five, fist bump, and all that fun stuff also. You can do either. But I'm going to warn you, though, that 2 is going to introduce fractions, and we don't want to do that right now. I want to have a happy video. Like Bob Ross, happy little accidents, little trees and all this stuff. I need this to stay nice for as long as possible. And I'm going to tell you the nicest ways to tackle that 3. So the opposite of plus a 3 is, not in yellow, is minus a 3. Then I'm stuck with 2 times x is equal to 6. 2 times x. The opposite of multiplication is divide. And notice I divided both sides by 2, just like I subtracted both sides by 3 up above. So they're all just properties of equality, and I get that x must be 3. This must be my answer. But wait, there's more. I need to check my answer. Every equation can be checked. So all I did was I plugged the 3 in for the x. We call it evaluating. And 2 times 3 is... Ooh. My computer didn't like me. 2 times 3 is 6. Plus 3 gets me to a 9. And well, guess what? That equals 9. I guarantee you that 99.9% correct. So now I want to tackle that idea. Is this thing linear? Well, there's the x. It's to the first power. I have the a and the b, but the 9 isn't the 0. Well, subtract 9 from both sides. And guess what? You'll have your 0. We don't need to focus on that. We need to focus on problems. So I'm going to go harder. Let's say I had 2 parentheses x minus 3 plus an x is equal to 3 parentheses x minus 1 minus 2. Please note I now have 3 x's. What does it mean to solve? Well, I need to get all those x's together, and I need to hopefully be able to combine like terms and get it looking like the last problem. But we have a few extra steps we need to do, and I need you to simplify the left-hand side and the right-hand side. Right? Don't worry about moving things over. Just see it as an expression is equal to another expression. So on the left-hand side, we get a 2x minus 6 plus an x. And on this side, we get a 3x minus a 3 minus a 2. Well, combine our terms. I have these things. I have 2 chickens plus another chicken, which gets me to 3 chickens minus a 6. And over here, these are my like terms. And I get a 3x minus 5. What does it mean to solve? Well, it means to get my x's on the same side. We have a problem, folks. This equation was not solvable. Our x's went away. When your x's go away, they can lead to a contradiction or to an identity. This one happens to be a contradiction because there is no way that -6 is equal to a -5. We call this guy the contradiction. And all this means is out of the infinite number of numbers, right? Cute ones, ugly ones, we don't care. Any of them will never solve this equation. Whereas to our previous problem, right, this guy's conditional. It is a good equation based on the condition that x is equal to 3. So what happens if I worked up an equation and all of a sudden I got like 2 is equal to 2 or -6 is equal to a -6? All of these are true. If you ever get something where the x's go away and you get a number is equal to the same number, 0 is equal to 0 is also very much suitable. We call this guy the identity. We call it the identity. And what does it mean? It means out of all the infinite numbers, every single one of them works, even the square root of pi. Okay. Speaking of pie, it makes me hungry. Come on, everybody likes pie. But seriously, it's called the identity. It means everything works. All real numbers, whatever you want to call it, we call it the identity. Right. So my main focus on this one was, 300, a little bit of 303, maybe even 0014, just to get us started, right? And we will make some more videos on this, but until now, this is a good step in the right direction, right? Have a good day, folks.